Alright, your first question is probably what? Why is the motor on the bench? And then second, what are all these parts? So in trying to figure out what size pulley to get, I really didn't like my options. I was going to have to go to like a 15 or a 16-inch pulley, and even that may have not been good enough. The other thing I didn't like with the large pulley is it blocked clearance underneath the press. I can just slide my pallet jack under there and move it around. With the big pulley, that pulley would be in the way and I wouldn't be able to move it around that way, so I don't like that. Could have went gear reduction or something like that. All turns into a big mess. So I started looking around when I was looking at pulleys, and I found this pump right here. Here's the pump. So this is a two-stage pump. It pumps 13 gallons a minute, up to 500 psi. When it hits 500, it shifts into a low gear. Basically, it's a second pump, and that pumps at only 1 gallon per minute. Okay, so 13 and 1. So this is really, really low, which means we can use a lot more of the torque of this motor. Okay. They didn't say what the RPM specification on this was, but it was recommended for a gas engine. So that tells me that this is probably measured at 3,600 RPM. This is a, what is it, Maruzushi pump, manufactured 2006, but it's brand new. This is at Surplus House in Nebraska. So I think this is going to work real well. So I went online, I found a hydraulic horsepower calculator at 3,000 psi, which is what this pump does, at half a gallon per minute, because the motor is only a 1725 RPM. This is 3,600. So this will only pump half a horsepower at 3,000 psi. That is 0.875 or 7/8 of a horsepower, which means that I should be able to get full pressure on this pump without stalling the motor. Okay. So the other thing to look at here on this pump, it's got a nice little arrow here. It tells you that it turns this direction, which, looking at the shaft, that's clockwise. So I'll have to make sure that the motor is wired to go that same direction. The motor is reversible, so that's not a problem. Okay. This is a adapter mount for the pump, so it will fit that pump housing and bolt on. Gives me an access port to put the coupling on, and then this mounts up to a C-face end bell. They call this a C-face. So that just fits on there, and then that bolts on, and then you couple the shafts together on the inside. Okay, so this is a C-face conversion for this motor. It's a 56 frame, lease and farm duty. So this frame is made for this motor, or this end bell is. It came with a conversion kit and some, which is really this, and this little pack of washers and some instructions on how to actually switch this motor out to have this end bell on it. You have to shorten the through bolts, because on the existing motor, these through bolts actually come through this face, and we'll actually unscrew them right here. But on the C-face, they just screw into the back of the flange here, and that's a blind hole. And then the front side of the hole is used for the bolts to mount the housing on. So those bolts can't be too long, or it won't pull this up tight correctly against the face of the motor and hold it together properly. Alright, then we just got a little coupling here, two coupling pieces, one for the motor, which is 5/8, one for half, which is the pump, and then the little rubber cross. I bought an extra one while I was at it, because these things were like 50 cents. So if ever goes bad, I have another one. So that should fit everything together. Hopefully we have the right shaft clearances when we put it together. I never actually checked like this just to see if it would go. Oh yeah, there's definitely going to be enough clearance in there. There we go. You should be able to see that. about a ½ inch in between those two shafts, which is just about right. So that's gonna work. All right, so I'm gonna clear this off and we'll get into this motor and start putting the C-face on. All right, much of this is gonna be the same as it was when we did the teardown inspection of the old motor and found out that it was junked. It could still be repaired, really just needs a centrifugal switch, and lo and behold, I'm doing a new end bell for the front here, but the rear end bell was actually spun a lot worse than the front, if I remember right. So we're just gonna go ahead and keep using this new motor. Alright, we got a circlip there. That fan guard makes a nice parts pan. Alright, you'll find a lip, just tap real gentle, hit the other side, these just pop right apart. You just got to keep working them back and forth. Using our key here, get rid of our flinger ring. That's a little rubber dust washer that keeps dirt from getting inside through the clearance hole for the shaft. Alright, we're gonna pop the back too. Actually no, I'll mess with the back because the centrifugal switch is in there. Wow, sure does get rusty just sitting in storage. That's what proper brand new windings that haven't been burnt looks like. That's real unusual. Look at that little curly Q in there. That's a winding defect. I think really shouldn't have that. I'd have to ask my dad for sure. Alright, we're going to set that aside. End bell should just push right off. It does. Watch out for the edges on that fan. They're kind of sharp. Okay. Now we can get into our instructions on how to put this new end bell on. Alright. Remove it. Add grease to the ID of the bearing bore on the C-face. Alright. I need some grease. This is just some regular gun grease. Thin coat. Alright, this is a 56 frame motor. It says to shorten these bolts by cutting off 15/16 of an inch. We'll do that, but not yet. Alright, remove rotor and shaft. Remove the wavy spring from the current end bell and set aside. So there's your wavy spring. Alright. Remove the shim from the lead end of the end bell and replace with the wavy spring. Alright. Let's get that back over here. Okay, so there should be a shim down in there. There is. Alright, we're going to put the wavy spring in there. If you have trouble with your wavy spring staying in the hole, when you're putting it together, you can just set the motor up this way. My dad, every now and then, some of them, if they're too big to do this with, he just put some grease on the spring, and that would hold it in place just a real little bit, just enough to stick it down. Okay. Place the shim in the bearing bore of the C face. Okay, we're probably done with that. Which means we have a new end bell for that other motor, which is excellent. Alright. Place the 4 provided lock washers on the T-bolts. Insert the T-bolts in the motor through the lead end. Do not disturb the motor leads. Blah, blah, blah. Install the rotor shaft assembly and the C-face end bow. Alright, so after helping my dad with tons of these and watching him do tons, you put your rotor in first. Don't mess your windings up. Okay, now our wavy spring is in the back. It's doing its job. We'll put our end bell on. Our witness marks in the front didn't do us much good. What I'm going to do, I'm going to grab the other one. Find those witness marks. Oh, there's the bottom. There they are. Alright, and I'm just going to mark where one of those bolt holes lines up at. Okay. So they got these little clamps. These actually clamp onto the back of the bearing to hold it. You want those turned away so this can slide right on. Okay. That should line up about right. Now we're going to keep our bolts long for now and try them out. Alright, you can feel when you got it in there straight. Then you just gently tap this face in. Work your way around and it'll just seat right in. That's fitting perfect. There. Now you can see why we need to shorten this. If I go in all the way, there, I got that much sticking out. That ain't gonna hold the motor together. Alright. Alright, we'll cut these off. We'll be back. Alright, they say they cut off 15/16", which is 93/75. So we'll just mark that off with the grease pencil. Okay. And then most vice grips, they got this little bolt cutter deal in here. You gotta leave some separation. You aren't gonna go all the way through with it, but they generally work pretty good. You get that set in there and really give it some grip. There we go. And it just gives you a nice good cut there. You can just break the bolt off after you get that, and then go clean it up on the grinding wheel because it leaves quite a burr on there. Real nice now. Then we take one of the nuts and try it, because we don't, if there is a problem, we don't want to burr up the back of it. Next size up. We don't want to burr up that C-face end bell, that new one. We don't. If we ruin one of those holes, we're pretty well hosed. We ruin that end bell. So running that nut down there will help reform those threads and clean them up, make them fit right. Then we can go ahead and try it out over here. Alright, that's coming down nice and snug. We'll pull it out because we're supposed to put these lock washers on, and then we'll Get the other 3 cut, put it back together. When you put these snap rings on, always make sure they're in the groove. I even try to pull them tight, spin around and look. And then since these have flats, put those ends on in the open spot in the flat, so you don't have this gap where you need the holding power. Now I have a brand new, very happy C-face motor, ready for a coupling. Don't know exactly where this needs to go on the shaft yet. We're not going to tighten it because we don't know. Excellent. Do that some more. There. Now it's really easy to move by hand, so when we get in there we can put it where it needs to be. Hopefully it'll line up right there with the end of the shaft. Next we have the pump. So by the way, that's a 1/2 inch and that's the pressure fitting. That's still a 1 inch just like the other one. That's the inlet. And then this is presumably this is a relief that lets you adjust where it kicks from high to low. I'll probably just leave that alone because I'm fine with what it does. At least I think it is. I guess I can't really say I am because I haven't tried it yet. Alright. Now something really disappointing with this coupling, the 1/2 inch one, they don't have a keyway in it. Alright, I was able to make a keyway here. I just used the jigsaw with a metal cutting bit. I made 2 slots, cleaned them out with the round file and a triangular file. This stuff's pretty soft. It was relatively easy to do. I just like that a lot better because now there's actually something more than just this little set screw holding things together. Alright, now we gotta find the right size bolts for this. Things. Put together. They want just like a 1/16 inch gap in there. Now we have to turn it so we can tighten our set screw. There's the pump. By having these keyways now, the set screws aren't holding any axial rotational force. Sorry, not axial, rotational. They're just keeping axial forces in place. They're holding these couplers in their position on the shaft. The rubber grommet and the keyways are transferring all of the rotational force for us. This is so if you have any mice that want to live in here, they don't get ground up when you start it up. Now we have to set the rotational direction. The pump wants to go this way. Okay, yeah. 115 volt is this wiring diagram, 208 and 230 is this one. Okay, so you switch 5 and 8 for clockwise, facing the lead end. So looking at from this way, because I have 5 in with P2 and T3, it's going to be clockwise looking at it from this way. So that's the right rotation. It's going to turn the pump the right way. Good. So all I have to do is hook it back up and we're good to go. Since this is a fixed mount, we don't need to use the slots anymore. However, I'm going to be able to use a bolt in each of these two slots. This original mounting hole that holds this plate down, and only needed one new hole. And that should do it. I had to take off the old pump mount. It was interfering with the suction elbow. And everything's bolted down real good. Now we'll hook up the wiring and the hoses and try it out. Got everything put back together here. I like the look of this a lot better. It's real clean. Let me bring you around back. Same thing here. This suction and pressure line are touching right now, but we're just getting ready to test this out. I'll actually tie this suction one back so they're separated. You don't want hoses touching and rubbing on each other. They'll vibrate holes in each other, so that's not very good. Alright, so I'm going to set you guys up here on the bench, and then let's try this out and see what we get, see if it works. Sounds pretty good. I expect it to be noisy now compared to before, because that pump is running at full RPM. Let's see if we got pressure. Alright, it's moving. We're building pressure. Alright, excellent. Try the D10 out. That's good. Here's a view of what it looks like on the pressure gauge. There, it's building pressure. Now there's a relief going off in the valve. That's good, that's what we want. And then when you reverse, you can see it build pressure till the detent releases, about 1,000 psi. That's a pretty good setup, but the pump is rated to 3,000 psi, so I'd like to adjust that. So I think what's going on is this this nut here is covering up an adjustment screw that's going to set that for us. So we'll pop that loose. Alright, there is an adjustment screw there. I'm going to assume that tightening is going to increase the pressure. I'm just going to turn it a little bit. We don't have to put the cap back on, but we can try this out again. So let's check what we get for pressure now. Okay, that's 2,800. We'll tighten it a little more. Is about what I want to get to. We go a little more. There we go. That's like 2980 or 90. That's perfect. Alright, I'm real happy with that. That's what we want. Here's what it looks like in back. Now that everything's all tied up nice with the zip ties, the hoses aren't touching. The cord is tied up underneath here, so it's not going to get caught on anything. Got the shelf reinstalled. I'm going to probably end up making a new shelf, but I'm not worried about it right now. Just to get rid of that hole above the motor. I could move it to the other side, but then it'll be in front of the pump instead. And I have to put the guard back on the front. I really don't see a need to. The shelf is way in front of it, so nothing's really ever going to get in there and hit that. Alright, just kidding. You didn't really expect me to not show you what this thing can do, right? I don't even know yet. So I want to recover some bearings, some bearing balls out of this old bearing. So we're going to use the press to crush this, to split it open. This can be really, really dangerous because these parts will fly off There's plenty of channels on YouTube of people crushing stuff with these things. The safe way to do this is just wrap it up, use some fabric, this is just some old t-shirts, tie them up in there real good, and that'll catch all the pieces and it's safe for you to hang out by it. This is also a pretty small bearing, so we don't need a whole lot. That should do it. That sounds like it's done. Let's have a look. Perfect. There's the balls. Got 3 pieces on this race here, plus the dust guards. Put those in the art bin. And now to break the inner race. Same thing. Break the inner race, but it did separate the cage for me. And the balls are falling out. That's what I wanted, so I can get all these balls out. I'm using them in a turntable for a chair for the living room. Had a Lazy Susan in it. It had a graphite race that fell out and all the balls disappeared. So I'm just filling the whole race with balls of the same size. Alright, the press works. Does a good job. Didn't even hardly see any pressure on the gauge with that. Doesn't take a lot to break these. I think that's a 5-inch cylinder. So that puts this somewhere around, what is 2.5 squared, 625 times 3,000. So a 20-ton press. I think I'm doing my math wrong. I gotta totally be doing that math. Of course, is 625. I forgot pi times 3.14. 6 will do. That gives us 19.6 times 3,000 is 58,900. This is almost a 30-ton press now. Awesome. All right. 30-ton press. There it is. The whole unit was $20. That got me the frame, the cylinder, the valve. The pump was shot. That was junk. The motor's more or less junk. It can be repaired, but it was junk. I replaced all the hoses, but I got the reservoir, the filter housing, and all that, and all the metal work that was done on this. It's well worth the money. Between the hoses and the new pump and miscellaneous stuff here and there, that's about $350, $400. If you had to buy the motor yourself, and you didn't have a dad that had old inventory from his closed motor shop, you're looking at about another $200 for a motor like that. So all told, I'd still only have $600 in this new press like that's 30 ton. I don't even know what that would go for, but I imagine it's well into the thousands, if not $3,000 or $4,000. And I got to have some fun on the weekends, actually going through this thing and putting it together. This is a great time. So, yeah, I got a hydraulic press now. I got to track down some steel to make some new heads. All I have is this little, it's a wedge head. There were no other tools with it, so I'm gonna make some round flat tools to press things with. So that'll be next project for this. I also might lift it up about an inch or so. I might just use bolts for feet, flip them upside down and have them come through. I only need like a 1/4 inch, maybe a 1/2 inch or so of height, and then my pallet jack will slide directly under there. Right now I have to push it back and lean it to get the pallet jack all the way under there to move it around. But I don't expect to need to move it very often now. So, alright, that's it. Press is done.